Today topic of discussion is free radical. How to define free radicals? Free radical are the molecules or molecular fragment which contain one or more unpaired electrons. They are known as free radical. So molecules are molecular fragment which contain one or more unpaired electrons. Because of their unpaired electron, they are highly reactive. They are highly reactive. They causes generation of new radicals. Then they have very short lifetime or ultrasound lifespan, and they causes damage to various tissue. What are the special characteristic? They are reactive. They causes generation of new radicals, then very short lifetime, and they causes damage to various tissue. Coming to the name, it includes superoxide ion. These free radical represented by superscript dots. It is represented by superscript dots. This is first one. This is superoxide anion radical. This O2, the superscript, they represented superoxide anion radical. Then second one, HOO, this one, hydroxy peroxide radical. Third one is hydroxy radical. This fourth one is nitric oxide. Then this one is peroxy nitrate. Then other two, H2O2, this one hydrogen peroxide. Then this one is cyclet oxygen. These are two more reactive oxygen species which are reactive, causes new generation to new radical, very short lifetime. They causes damage, but they do not have free radicals. These two don't have free radicals, the two superscript dot. So because it don't have that unpaired electron, this is called as reactive oxygen species. All the things considered as reactive oxygen species. These two reactive, then new generation of free radicals also, very short lifetime also, but don't have unpaired electron. But from this superoxide ion radical to this one singlet oxygen, all are considered as reactive oxygen species. Reactive oxygen species. These two are nitric oxide and peroxide nitrate. These two are considered, this one also known as reactive nitrogen species. So these are the name of free radicals: superoxide anion radical, hydroxy peroxide radical, hydroxy radical, then nitric oxide and peroxy nitrate, hydrogen peroxide and singlet oxygen. These are the name of free radicals. Now the reaction of O2. This oxygen is converted into superoxide ion, then which is converted into hydroxy peroxide. Then hydroxy peroxide is converted into hydroxy radical, which is converted into water molecules. So oxygen superoxide ion, then hydrogen peroxide, then into hydroxy radical, then water molecules. These are the steps in is the reduction of oxygen and generation of free radicals. Reduction of oxygen and generation of free radicals. Oxygen to superoxide anion, then this one is converted into hydrogen peroxide, this one is converted into hydroxy radical, then water molecules. Reduction of oxygen and generation of free radical. Now coming to sources, there are number of sources of generation of free radical in our body or reactive oxygen species in our body. Some are endogenous, some are induced by some environmental factor, exogenous, some are endogenous, some are exogenous. So these are the two types of sources of generation of free radical. First we'll discuss about endogenous sources produced in our body. These endogenous sources produced in our body by various metabolic reaction. Important reaction, first one through electron transport chain. During oxidation of foodstuff, there is leakage of electron from electron transport chain which contribute to the free radicals. So during oxidation of foodstuff, there is a leakage of electron from electron transport chain which contribute to the free radicals. This is important sources. Second one is nitric acid synthase citric. Second one is nitric acid synthase citric. Here conversion of arginine to nitric acid with the help of nitric acid synthase citric. Production of reactive oxygen species. So here conversion of arginine to nitric acid with the help of this NOS. So here that production of reactive oxygen species. Then third one is NADPH oxidase reaction. This reaction, there is production of reactive oxygen species. There is production of reactive oxygen species. This can be explained with the help of respiratory burst. Respiratory burst, what happened? Whenever bacterial infection, bacteria get engulfed by macrophages, and for this they required oxygen, and there is increasing demand of oxygen for this bacterial engulfment by the macrophages. Now what happened? This oxygen is converted into superoxide anion with the help of cysteine. With the help of cysteine, that is known as NADPH oxidase, NADP plus. Then this hydrogen peroxide is converted into hypochlorous oxide with the help of SOD, superoxide dismutase. Then this hypochlorous oxide will kill bacteria. That superoxide anion also kill bacteria. That is why increasing demand of oxygen is there. That is known as respiratory burst. Oxygen is converted into superoxide anion. Then with the help of this cysteine, that is known as NADPH oxidase, is reduced into NADP plus. Then this superoxide anion converted into this hydrogen peroxide. Then with the help of superoxide dismutase, it will converted into hypochlorous oxide which kill bacteria. This superoxide will kill bacteria. So here, that's why increasing demand of oxygen. So it causes respiratory burst. Then xanthine oxidase reaction, that is uric acid. In this purine degradation, hypoxanthine and xanthine, they are converted into uric acid with the help of xanthine oxidase. In this reaction, production of this reactive oxygen species, reactive oxygen species. So xanthine oxidase reaction, purine degradation, hypoxanthine and xanthine converted into uric acid with the help of xanthine oxidase. Here that production of ROS, reactive oxygen species. Next, prostaglandin synthesis in the platelet. In platelet and leukocytes, lipooxygenase pathway, there is generation of reactive oxygen species generation. So here prostaglandin synthesis, platelet and leukocytes in lipooxygenase pathway, generation of ROS. Next one is lipid peroxidation. It is an important generation of ROS, reactive oxygen species. There are 3 steps of lipid peroxidations. Lipid peroxidation is the important source of free radical. Lipid peroxidation, it is important for generation of free radical. Lipid peroxidation is important for sources of reactive oxygen species. There are 3 steps of lipid peroxidation: initiation, elongation and termination. What happened in initiation stage? This RH, this is FUFA, polyunsaturated fatty acid. When it reacted with the hydroxy radical, there is production of one carbon radical or FUBA radical and water molecules. So this RH FUBA reacted with the hydroxy radical to form FUBA radicals or one carbon radical and water molecules. When this FUBA reacted with oxygen in aerobic condition, leads to the formation of lipid peroxide radical. This R radical, this one reacted with oxygen in aerobic condition. This one carbon radical or FUBA radical bind with oxygen in aerobic condition. It leads to formation of lipid peroxide radical. This lipid peroxide radical has tendency to combine with another molecules of FUBA, so RH, to form lipid peroxide, and one carbon radical. This lipid peroxide is the promoter or stimulator. This one is the promoter or stimulator of lipid peroxidation. So this RH will combine with hydroxy radical to form one carbon radical. This carbon radical bind with aerobic condition oxygen to form lipid peroxide radical. Then this lipid peroxide radical combine with another FUBA to form this one lipid peroxide. This one is the important promoter or stimulator of lipid peroxidation. This ROOH, lipid peroxide, is promoter or stimulator of lipid peroxidation. And this step, this propagation does not stop. This one do not stop that FUBA until FUBA get exhausted. It is known as propagation. This lipid peroxide is the promoter or stimulator of lipid peroxidation. This propagation do not stop until the FUBA get exhausted. That is, it is known as propagation or elongation. Third one is termination. When this free radical lipid peroxidation radical combined with another lipid peroxidation, when it is combined with other radical, termination will occur. Free radicals, that lipid peroxidation with combined with another lipid peroxidation, that time termination occur. Seventh one is auto oxidation of some metals. There is generation of free radicals. So totally endogenous sources. First one is electron transport chain. Second one is nitric acid synthal cystic, then NADPH oxidase. Then fourth one is xanthine oxidase reaction. Then fifth one is prostaglandin synthesis in the platelet. Then lipid peroxidation. Last one is this one, auto oxidation of some metals. They generate free radicals. Next, exogenous sources which induce the free radical production, which include alcohol, which promote lipid peroxidation. Second one is radiation, X-ray ionizing radiation that causes free radical formation. Then drugs metabolism by the cytochrome 450, which causes free radical formation, and smoking. These are the environmental factor which causes free radicals. So these are the sources of free radical, exogenous and endogenous. Next, coming to the disease related with free radicals, which are important in the free radicals. What are the diseases? Generation of free radical which occur in number of disorders. The importance are atherosclerosis, acute inflammation, aging, bronchoalveolar diseases, cancer, cataract, cardiovascular disease, and diabetes mellitus, etc. These are the important disorders related with free radical production. What are the diseases? Atherosclerosis, acute inflammation, aging, bronchoalveolar disease, cancer, cataract,